we are going to make comparisons with percentages, and we are going to do that by writing proportions. Now, there's multiple ways to do these problems, but I am a huge fan of proportions because for me, it's easier to really write it out and visualize. So we're going to show that in each one of these problems. So first, Indiana's 2021 population is 6.7 million. This refers to the 2021 population. So the 2021 population is 9.8% larger than the 2001 population. What was Indiana's 2001 population? Now, I'm a very visual learner, so I like to write out what am I finding. Now, I'm comparing the 2021 population to the 2001 population. So when I set up my proportion, one ratio will be the populations, one ratio will be the percents. So let's go back to our problem. 2021 population is 6.7 million. This is 9.8% larger. That means 2001 is the reference of 100%. And if we are larger than that, then I'm going to take 100 plus 9.8, and I get 109.8. So there's the percentages. And what was Indiana's 2001 population? The big key here is setting up the percent ratio. You've got to figure out which one of these items is the reference and then go by larger or smaller, whether you add or subtract. So it's larger than 2001. That's how you know 2001 is the reference. Then to solve, we cross multiply. So 109.8x equals 670. Divide both sides by 109.8. And we get approximately 6.102 million people for the population of Indiana in 2001. We're going to do that same process for every one of these problems. So in number 2, Lafayette's population is 15% less than Bloomington, which has 82,000 people. Find Lafayette's population. So we are comparing Lafayette to Bloomington. Again, we are comparing population to percent. So go back and say, okay, what do we know in our problem? Well, Lafayette's population is 15% less than Bloomington. That means Bloomington is our reference, and we are 15% less. So I'll take 100, minus 15. So that means Lafayette, for a percentage, is 85. And then it says Bloomington population, which is 82. That means Bloomington is 82,000. Lafayette is our unknown. Again, we cross multiply, so I have 100x equals 6,970,000. Divide both sides by 100, and we end up with a Lafayette population of 69,700 for Lafayette population. Number 3. For some of these, you really should hit pause, try to do them yourself, and then come back and check them out. So Indianapolis has a population of roughly 882,000, which is 68.3% less than Chicago's population. Find Chicago's population. So we're comparing Indy to Chi-Town. Again, we're talking population. Our other ratio will be percents. What do we know? Indianapolis population 882,000. Which is 68.3 less than Chicago. So Chicago is the reference. And it's less, so we're going to subtract 68.3 to get 31.7. Find Chicago. So again, we cross multiply. So I end up with 31.7x equals 88,200,000. I divide both sides by 31.7, and I end up with a Chicago population of approximately 2,782,334, rounded to the nearest person. All right, enough of population. Let's move on to money. Jerry is currently earning $20 an hour at his job. He was just informed he will get a 15% increase of his current wages. How much will he be earning? Okay, so what are we comparing? Well, we're comparing his current wage versus his future wage, right? And we are comparing money to percents. So let's go back. Currently, he's earning $20. So dollars current is 20. He was just informed he will get a 15% increase of his current. That means current is the reference. So current is 100. The future would be 115. And we are trying to find his future wage. So we cross multiply and we get 100x equals 2300. Divide both sides by 100. And x equals $23. So Jerry's future wage will be $23. Number 5. By the way, there are 11 problems total. You can watch as many or as few as you'd like. The number of hardwired residential phone lines is expected to decrease next year by 18% with the widespread use of cell phones. There were 1.8 million hardwired residential phone lines this year. How many are expected next year? So we are comparing this year to next year. We are talking about the number of hardwired lines and percentages. So there's kind of my framework. Let's go and look. So the first number I see is we're going to decrease by 18%. The number of hardwires is expected to decrease next year. That means next year, this year is our reference because it's going to decrease next year. So if this year is 100, then next year is going to be 82. Because it's decreasing. So hopefully that kind of makes sense. Then we go through and we say, okay, there were 1.8 million hardwires lines this year. So 1.8, we're trying to find next year. We cross multiply and we get 100x equals 147.6. Divide both sides by 100 and x equals 1.476 million. Hardwired lines expected next year. Number 6, Pete paid $350 for an iPad, and Elaine claims that was 20% more than she paid for her Samsung tablet. How much did Elaine pay? Okay, so we can either go with iPad versus Samsung or Pete versus Elaine. And we're talking about money and percent. Okay, so for Pete, he paid $350. Elaine claims that was 20% more than what she paid. So if Elaine paid 100%, Pete paid 120%. And we find the unknown. So we cross multiply. We get 120x equals 35,000. Divide both sides by 120. And we would expect that Elaine would pay roughly $291.67 for her tablet. Now, part B of this says, does subtracting 20% of 350 from 350 give the same result? Well, 20% of 350 is the same as saying decimal times 350, which is 70. So if we subtract 70 from 350, we get 280. Are those the same? No. And that's because it depends on the reference. In part A, Elaine is the reference, and the way we did math in part B makes Pete the reference. So you have to really pay attention of who is the reference because that is going to change your answer. In number 7, Megan is currently enrolled in 16 credit hours, but wants to decrease her credits by 25% over the summer term. How many credits will she take in the summer? So we are comparing the current term to the summer term. We are talking about credits versus percents. Currently, she is taking 16 credit hours. She wants to decrease that by 25%. So if she is currently in 100%, we want to decrease that by 25. So she wants to take 75% of that for the summer. We cross multiply. We end up with 100x equals 1200. Divide both sides by 100, and we find that Megan wants to take 12 credit hours over the summer. Number 8, let's talk taxes. If the take-home pay is $1,443 and 22% was withheld in taxes, what was the gross pay? Now, this becomes a little easier if you understand the difference between take-home pay and gross pay. If not, it can be a little tricky. So we are comparing take-home to gross, and we're comparing money to percents. Okay, so we know the take-home pay is $14.43, and 22% was withheld in taxes. Now, if the gross pay, when you work at a job, the gross pay is the amount that you earn, and then from that, they withhold taxes. So you would, in this case, get to bring home 78% of that. So we can use the 78 over 100 to find our take home, or our gross pay. So we cross multiply. 78x equals 144,300. Divide both sides by 78, and we end up with $1,850. So $1,850 is your gross pay. That's how much you earn before taxes. Number 9. Julianne recently joined a carpool. Although she lives 22 miles from work, on her day to drive the carpool, she drives 30% further to pick up her colleagues. How far does she drive to work on her day to drive the carpool? Okay, think through what this is asking. We're saying she's either going to drive to work by herself and have a certain amount, or she drives the group. So we're talking about miles compared to percents. So we know she lives 22 miles from work. So if she drives solo, she would drive 22 miles. On her day to drive, she drives 30% further than that. So if solo is the reference of 100, 30% further would be adding that. So she would drive 130% of what she normally does, right? So we can use that to find our group mileage. When we cross multiply, we get 100x equals 2,860. Divide both sides by 100, and x equals 28.6 miles. So on her days to drive carpool, that's how far she drives. And number 10, Avatar, great movie, earned $2.85 billion in 2009, breaking the worldwide box office record previously held by Titanic, also a decent movie, by 29.5%. How much did 1997's Titanic gross at the box office? We are comparing Avatar to Titanic. We're talking about money versus percent. What do we know? Avatar earned $2.85 billion, breaking the worldwide record held by Titanic by. So that means Avatar is more than Titanic by 29.5%. So Titanic will be our reference because Avatar beat it by 29%. That's addition. So 129.5 would be my numerator. We're trying to find the amount for Titanic. So we cross multiply. 129.5x equals 285. We divide both sides by 129.5 and end up with roughly 2.2 billion. I rounded there. So this is telling us that in 1997, Titanic grossed $2.2 billion at the box office. And last but not least, Jane spent $18 on lunch, which is 25% more than what Barb spent. How much did Barb spend? So we are comparing Jane to Barb. We're talking money, 2%. What do we know? Jane spent $18 on lunch, which is 25% more than Barb. So Barb is our reference, 25% more, so we add the 25. We're trying to find the amount that Barb spent. Cross multiply, 125x equals 1,800. Divide both sides by 125, and Barb spent $14.40. So you can see how in each one of these we set up the proportions. I labeled everything because sometimes I get distracted and I start looking at other things. So it's nice and easy to label your ratios, label what goes in the numerator to denominator, and hopefully that makes things just a little bit easier. Thanks.